These videos will be on section 2.2 of College Algebra in Context, fitting lines to data points and modeling linear functions. If the first differences of the data outputs are constant for uniform inputs. Uniform inputs means like you're counting by something. It can be 1, 2, 3, 4, 5, or it could be 5, 10, 15, 20, as long as you're counting by something. The rate of change is constant. That means the slope is constant. And a linear function can be found that fits the data exactly. If those first differences are just nearly constant, they're close but not exact, a linear function can be found that's approximate fit for the data. That's what we're going to be working on in this section. This table gives the annual retirement payment to a 62-year-old retiree with 21 years or more years of service at Clarendon State University as a function of the number of years of service and the first differences of the outputs. So 21, 22, 23, 24, 25 years of service. So those are uniform. Here's the retirement payment per year. And if you see, these are the first differences. So it's the difference between these two numbers. And it's how much it goes up. So this was an increase of 1,950. This was an increase of 1,950, an increase of 1,950. This constant increase. That's the first what we mean by first difference. Change then here is the constant 1950. That is, rate of change means slope. Using this rate of change in a point gives the equation of the line that contains all the points. So we're using point slope form. Representing the annual retirement payment by Y and the years of service by X, using this point, then this becomes our X and this becomes our Y. For this ordered pair, we can get the equation Y minus 40,950 equals 1,950 times X minus 21. Simplifying that, we found out that Y equals 1,950X, and this becomes our equation. We have a constant difference, we can find that. Now, note that the values in this table represent points satisfying a discrete function, a finite number of inputs. We were counting how many years of service, 21, 22, 23, 24. We didn't say 21 and a half or 25 and 3/4. Although only points of the integer inputs represent annual retirement payments, we could model this with a continuous function, y equals 1,950x, where the graph passes through the 5 data points. Informally, a continuous function can be defined as a function whose graph can be drawn over its domain without lifting the pencil from the paper. That's continuous. Make the discrete interpretation to the model. Only inputs of the function that make sense are non-negative integers representing the years of service. And here are those things. So just the scatter plot, we have the dots. When the scatter plot is approximated by line, we get the best fit. So this is the line of best fit for these dots. And because it is that y equals 1950x, and that worked for all of them, we had a continuous first difference, a constant first difference, we can get that equation. Fitting lines to data points. This is called linear regression, a procedure that defines the best fit line as the line for which the sum of the squares of the vertical distance from the data points to the line is minimum. And officially, we could calculate all that by hand. Luckily, our calculator will do it for us. To have our calculator do it for us, first we enter the data into lists. We create a scatter plot of the data to see if it looks like a line is going to be reasonable. So if it's going to be a linear model, it should follow a linear pattern, no distinct curves. Using the graphing utility, we can get the linear equation that's the best fit. We graph the linear function unrounded and the data points on the same graph to see how well the function fits the data. We report that function and our numeric results in a way that makes sense in the context of the problem with appropriate units and the variables identified. Unless otherwise indicated, report functions with coefficients rounded to 3 decimal places. Unless they tell us different, we use 3 decimal places to report them. But when we do calculations, we use the unrounded function. After the model for the data has been found, it can be rounded for reporting purposes. Rounded for reporting purposes. Unless otherwise given other directions, round to 3 decimal places. However, do not use the rounded model in calculations, and do not round answers. Do not round answers during the calculation process unless instructed to do so. When a rounded model is used to find numbers, the answer should be rounded in a way that agrees with the context of the problem. Here's a set of data. This is the enrollment in thousands of grades 9 to 12 in U.S. public and private high schools in the years 1990 to 2009. So how many thousands of students were enrolled? And if thinking of these are thousands, you'd add 3 zeros. This starts with 12 million something. Here's what we're going to do with this data. We're going to let X equal the years after 1990. So we're going to subtract 1990, and Y equals the enrollment in thousands as it's already written. We're going to create a linear model that has enrollment as a function of the year, and we're going to graph that linear function and the data points on the same graph and talk about how well the function models the data. We're going to enter some data. So we'll go here to edit. Now, we already have data from something else we entered before. So the way to clear that is use your up arrow, put clear, and enter. Then you can go to the next column, use the up arrow, clear, and enter, and that will clear that data. Now they did ask us for the years to use X as the number of years after 1990. So our first number is 1990, so that will be a 0. 1, 2, 3, 4, 18, and 19. Now we'll go to the other column, and they ask us to do it in Y equals the number of thousands. So instead of 12,488, it will be 12.488. I would caution you to make sure and check periodically to make sure you are putting the data in correctly, because incorrectly entered data will end up with wrong solutions. And if I were checking a quiz or something, I will never see what's on your display. So you will have to make sure that you have entered it correctly.